All right, peeps. Here we go with the last paper. I don't know what you call it, page, whatever. This will be the third page. A lot of this is review, so I'm going to blow through this ABC. It's all repeats. So A, cross period smaller, down the group is larger, and smaller because more attraction, larger, more orbitals. Again, we're repeating ourselves over and over on this. These pairs, C versus O. C is going to be bigger, less valence than O. PAS. AS is bigger because it's got 4 orbitals and P only has 3. BESR. SR is way bigger, 5 orbital versus 2. And INSB, where are you at? INSB. Okay, I see it. IN is less than SB valence-wise. This wants to know like K versus K plus or Cl versus Cl negative. So I just wrote in general. Positive ions are smaller, negative ions are larger. But when we get down to these ones, the weird ones, I'll show you, walk you through on these weirder ones. So here's an Al versus an Al plus 3. Like I said, the positive is bigger. Whoops. Well, I screwed that one up. Let me erase that one. Al plus 3 would be bigger. N3 negative versus O2 negative. I wrote here 7 positives versus 10. Excess negatives makes you bigger. This says 3, this says 2, so that's bigger. Mg plus 2 and SR plus 2, both in the same group. Here, this is easy. Just go with the orbital concept, and we know that's bigger. Ca plus 2 and Se minus 2. Well, when Ca loses 2, it's going to end up looking like Ar, which you can see where that is on the chart. And Se minus 2, when it gains, is going to look like Kr. So we got to kind of look what they look like when they're done, and that one is going to be bigger. Remember, negative ions are larger than their counterparts, so that one's that one. And then Sb negative 3 and N negative 3 purely on the orbital concept. This one, I broke this one down, a little harder one. 3 pluses, 2 minuses, 1 extra polar. 4 pluses, 2 minuses. It's got 2 extra polars. This one's actually smaller, so that's bigger. And then Fr is a really easy one because that's the biggest on the whole chart. And that'd be because of the 7 orbital, 1 valence concept. All right, here we go. Repeat here, energy need to remove 1 valence electron. And now this is going to be new to you guys. IE1 is the energy needed to take off 1 valence. IE2 would be the energy it takes to remove the second one off. And then IE3 would be how much energy it takes to pull the third dot off. So you really got to know your Bohr model structures. And then I know a lot of you had problems with this section. So my daughter's filming, she's doing a good job. But I'll try to walk you through what this is all about. So energy needed to take off 1, energy needed to take off 2, 3, and 4. Basically what you want to do here is you want to look at the numbers as you go across, and you're going to look where it increases the most. So in element A, it jacks up on IE2. I mean, it keeps going up, but the biggest increase is IE2. So what that means is it's really easy to remove 1 dot, but when you go to remove the second, because you're noble, it's going to take a large amount of energy. So this A is a group 1 element. Lithium, sodium, potassium, any of those. B, we're going to look at the jump. So 740 to 1500, and then 1500 up to 7700, you're jumping on the third. So it means it's easy to pull off 1, easy to pull off 2. Now we're noble. So basically where the circles are is where you're at a noble gas. So if you want to know what group you came from, find your noble and go back 1. This is group 2 because it's IE2. Okay, C. See how it spikes at IE2? Group 1 element. And you can see these two spike at the same ionization energy. D spikes on the third, so this is a group 2. And then E, 1, 2, 3, 4, spikes on the fourth, so it's a group 3 element, or group 13. I'll put 13. That would be like aluminum. So if you draw it out, and I'm going to do this real quick because her arm's getting tired. If I look at where it spikes at IE2, it would look like this. So really low here for IE1. But then when you go to rip the second one off, it's a really high IE2. So that's like letter A, where it spikes at IE2. Now, if we look at letter B, B does this. This is A, this would be B. B does this. Low first, low second, but then when you go to rip this third one off, it's a high third. So see how we spike at the third high. Okay, I'm sorry, this is the best I can do for you guys. It sucks not being there. So now we know the answer to A. Which of these elements is most likely to become a +1? That would be anything in group 1. So A and C, because they spiked at IE2. Excuse me. And then the last one, the ones that belong in the same group would be the ones you circled the high spike at. So AC are in the same group, group 1, and BD come from group 2. This guy's a loner. He's like group 13 over there, aluminum, gallium, boron, things like that. Well, I hope you guys are doing well, and I hope this helps you out. Miss being there with you guys. Let me know if you need anything. I'll talk to you later.